1998, number 76. So we're looking for the false statement. So let's read each one. First statement, f is continuous at a. Clearly, it's not continuous. So let me talk about continuity. So for a function to be continuous at a, f continuous at a, or x equals a, three things must be equal to each other. As I approach a from the left, it must come to the same value as I approach a from the right. That should make sense. To be continuous, both directions, I need to approach the same value. But the last thing is to prevent a hole at a, the value at a must be the same as you approach from each way. So as I approach from here, it has to approach some value. As I approach from the other side, it has to approach the same y value. And at a, it must equal the same y value. And you can see this fails because that point does not equal the limit from each side. So that would be a false statement. Let's continue on with some of these other ones. I'm going to skip B for right now, and we'll talk about that. So next one we want to look at is the limit exists. For the limit to exist, what that means is the limit as x approaches a from the left must equal the limit as x approaches a from the right. We can see as I approach from the left, it approaches a y value. As I approach from the right, it approaches the same y value. Since those are equal, it exists. So that is true. This one here, the limit from the right is equal limit from the left. Basically, these two statements are exactly the same. That's true. X is in the domain of f. To be in a domain means that the function exists at that point. Does the function exist at a? Yes, I see it right there. There's a dot. So that's true. Now the relative maximum, we got to be careful with this one because you think, oh, there's a relative maximum when the derivative changes from positive to negative and the first derivative 0 or does not exist. Okay, that is true, and that's what we use to prove, but this is a kind of a different situation. You wouldn't actually find this relative maximum doing that test because you'll see the derivative is positive on both sides. This one you wouldn't actually find. So that was a method we used to find and justify, but it's not the only case of a relative maximum. A relative maximum means at a, the y value there is bigger than all y values around it, which is true. That's why that would be a true statement. So our false statement is A.